Okay, here's what I released to you guys. So what is this file? This file is a wireshark capture. How many of you didn't download it? I will wait for a while. Please download it. Okay, because the screen resolution here is not as good. Or I cannot discuss with you some of the properties that I list out in the Facebook. In the Facebook, I list out some of the properties. What are they? Okay, so what? This what? So where is Stanley? Stanley is not here. Okay, M dot is not here. Oh, okay. So what I share to you guys is okay. I talk about several features. We will look at three-way handshake. We will look at packet loss, duplicated acknowledgement with SACK information, as well as fast retransmission, why it's happened, when it's happened, then connection tear down. Okay, so let's go. No, where's? Okay. Come on, baby, where are you? Here. So we have a three-way handshake here, right? Can you see this? Can you see this? There is a sequence number starting with 0. Okay, this is a bad resolution. Okay, if you have your own notebook, okay, please use your notebook to do the same thing with me. We have a sequence number 0, and this is the feature of wireshark. What is the feature? The feature, it says relative sequence number. Why I say that there is a sequence number which is relative and why I mention it? Let's take a look at my, where's my lecture notes? Sorry about that. My lecture notes, where are you? Oh, hiding here. Okay, so this is my lecture notes, and I go to the page that last time I talked about, the three-way handshake, right? Oh, no, not this. Three-way handshake, where are you? Okay, so last time I talked about one feature. The feature is the random number A and B, okay, to indicate the start of the sequence here and here. But look at the wireshark capture. The wireshark capture tells you another thing, right? How to read this? You click on the first packet, open it, the transmission control protocol, so the TCP, right? You open it, and then you will find that it says the sequence number is 0. It's contradict to what I said, right? I said that it is not 0. It should be a random number. Now this is the feature of a wireshark. If you don't like this feature, you can do the same thing as me. Edit, preference. Okay, wow, what is this? So I want to have when it's zooming, it's become something like this. Go to protocol and type TCP. Okay, so in TCP there is what we call relative sequence number. Okay, remove it. Okay, remove the relative sequence number. Apply. Good. And OK. So look at it again. What is sequence number? Okay, so where's my laser? Yeah, it's being locked. Yeah, I know. I want to have laser. Yeah. The previous professor only took out the mic without the laser. I need to log in again. Okay, password. Okay, good. So the laser. Here, okay, sequence number is actually it's a random number. So because this wireshark is for you to learn about the networking, okay, so it's very friendly in order to reset it into 0. Don't let you to see this random number, okay? So you can see this random number appear in the second second packet of the three-way handshake. I'm highlighting the second packet. The second packet, you can see two random number now. Okay? Another random number start with a 26 something to indicate another flow. Okay? So, well, basically, no one loves random numbers in this way. So I will unset it. Unset it. Go to protocol, type TCP, and turn on the relative random, non-random anymore. Okay. Then you can see this. Okay. I don't want to highlight it. Use the laser. Sequence number is 0, but the acknowledgement number is 1, and it said it's relative ACK number. Okay. So this is a three-way handshake. Second packet. The third packet, you will see this the sequence number and the acknowledgement number all are 0 or 1. Then they are ready to start the transfer. Okay? So tell me, what is this packet? The fourth packet. We go to the fourth packet. What is this packet? Can you find in this screen, what is the length of this packet? Can you see a field saying the length? Not header length, the length. Can you find it? In this screen. And I see all you guys look at the wrong place by looking at projecting your eyesight. The length is here. Right, I see many people look at this area now. This is the length. Okay? So remember, when you look at a wireshark capture, look at the length. The length is 1448. Okay? So that means that this carries some payload, not just the TCP, but as well as the application payload. Now, where can you find the application payload? Is here, data. Okay? So what is the data? Yeah, stupid data, all are 1. I just send all ones to the server, okay, from a client to the server. Okay? So I send out how many bytes? 1448 bytes. Okay? So by knowing that the length of data, 1448, and the starting number of the sequence number start with how many? How many? Where is the sequence number? 1, right? 1 here. So you will expect, what is the next sequence number? The next sequence number will be current sequence number 1 plus 1448. And wireshark is so clever, it's already tell you what is the next. It should be 1449. Now let's take a look. Where can you find the 1449? This guy, the fifth packet. The fifth packet is 1449 sequence. So it's indicated it is an other piece of data, not something that with transmission, but start with a new sequence number, continuing the previous 1, and then add 1449, and then go to 1449 plus 1 more. What is the length here? Yeah, what is the length? Another 1448. Okay? And the story goes on. Now I don't want to go through every packet. I want to go to some point that I want to highlight. So can you see some ugly color here? If you're using your computer, you will see some ugly color. It says TCP previous segment not captured. What is the meaning? It's feel that, okay, you should send in something in a sequence, not out of order. And suddenly find it is out of order. Okay? And then it starts giving you some ugly color, more ugly color. Okay? Each ugly color is to indicate something wrong. Okay? So what is something wrong here? I zoom in a bit. It says TCP duplicated ACK. Okay? So what is the characteristic of a duplicated ACK? Still remember? No one, right? No one remember. Okay. Only I remember. Right. Okay. So what is the characteristic of a duplicated sequence? Okay. Still remember this name? SACK? The selective acknowledgement? So where's the selective acknowledgement handout? Here. Okay. So this guy, when it's sent to here, is use a duplicated acknowledgement, right? But whenever you have a duplicated acknowledgement, please take a look at the TCP option. Whether we find this linked list of broken packet. Okay, so let's go to there to have a look. Okay, I now click on the ugly color. It already tells me that something wrong with some stupid color. And look at the option part. Option is give you a keyword, SACK. So it means inside this TCP option, we have SACK information. Let's take a look. Okay, so I zoom in a bit. It tells you that, well, inside here, it memorized what is the left edge. So that means a start of a broken out of order trunk and the end of a broken out of order trunk. Okay, so you can see this is really happening. And with one duplicated acknowledgement, 1, 2, I need to zoom in, okay. Okay, I need to zoom in a bit. With one duplicate acknowledgement, second, third, and then immediately it will trigger TCP fast retransmission. Okay, so everything I said in the PowerPoint, it seems to be so trouble. Okay, it's actually hiding inside the TCP flow. Okay, I won't go deep. Okay, the last thing. Okay, I can highlight it. Can you see this? Fin add, four-way handshake. Okay, the four-way handshake happening at the end. Okay, I share this to you guys. Okay, now how about examination? With examination, I ask you to come to a computer, open up a wireshark file, and ask you, hey, what is this packet? What is this packet? No. Okay, but I will do it another way around. I will create a table, okay, write down some fields, okay, in the examination paper and ask you, hey, if I lost a packet, okay, what should be the correct sequence number, something like that, okay? I remember I sometimes would set up this kind of strange questions, okay? Get prepared. Okay, so let's go back to the lecture. So remember last time I talked about this, okay? How many of you have go back home and try to not control C your server? Right? You know, whenever you control C the server, you will be the active guy who start the termination of the TCP flow. You are the active side to turn off the TCP flow. You will be the one who wait for. Why are you shaking? Huh? Okay, is this my computer shaking or something else? This time wait is to guarantee that if this ACK is lost, the B, the endpoint B, keep repeating this fin, you still have the socket to protect the entire flow that this fin retransmission will get attention, and eventually you can retransmit this ACK successfully. Okay? So remember, the one who actively close it will have the socket being occupied for 1 more minute. Okay? So that means that you don't control C server. Or control C server, but you implement something extra. Okay, so this is the flow of the four-way handshake. So the four-way handshake will have A and B here. Why? Okay, because it may have something stopped already. I don't know for how long the flow is stopped, so I set a sequence number to be 2 unknown number A and B. Okay, then it may also carry some extra data. The data will sometimes come with the fin. Okay, then the fin come in, you will acknowledge the fin. If you have data, then you will add the data length plus 1. Plus 1. In order to tell me that this is to acknowledge the fin. And then what? And then I will repeat the same combination, B to B, A plus data plus 1. The same combination happen again, but this time I will add a fin at here. Now let's take a look at the wireshark capture. Is it the same? Okay, so this is fin, this is add, okay, and the add Wow, even I cannot say, okay? So look at the direction. The one to highlight is the first packet of the four-way handshake, the second, third, fourth. The second one and the third one come with the same direction, right? From here, this is the source column, this is the second column, same direction. And now we know they come in a pair because of the previous diagram in the lecture notes. Now let's take a look at, wow, very hard to control when I zoom in. Okay, let's take a look at the sequence number and the acknowledgement. Okay, is first and second. Oh, my note says something wrong. Okay, yeah, it will increase one in order to tell that it is a little bit different here, and then add one more to indicate that this add is also special. Okay. Wait, I can change it. So add one more here in order to say that this add is special. So this is a four-way handshake. Any problem? Any problem? No. Okay. So then we will come with a famous thing. Okay. What is this famous thing? This is not something famous. Let me show you something famous. The famous thing is called wow. Yeah, you cannot see it. Okay, I will delete it in the capture. Okay, so can I switch to ELG wave? ELG is more trustworthy. Okay, did I log in? Okay, I have logged in. Good. Okay, so what I'm going to show you. Hey, come on, Google. TCP state diagram. Wow, okay. So we have so many state diagram, okay? Let me click on a random one. Is it big enough? Or, okay. So what is that? What is that? Yeah, this is a state diagram. I can tell you that this state diagram usually will be on the back or on the front of some textbook. Okay, maybe in the appendix, maybe in a behind the cover. Okay, this is a very famous state diagram, and every machines, no matter your cell phone, your Mac, your Windows, Linux, all implementing this state diagram. But this state diagram seems to be large. Okay, so I just copy and paste the textbook state diagram. The textbook state diagram, cut it out into 2 parts. So what is 2 parts? With the active side state diagram. So that's why because I capture from a textbook, okay? So it's become some screen capture dirty thing here, okay? I don't know why it became dirty. This is the active side. Originally it is closed. So what is the message here? Close means that I didn't even start the socket. Okay? After I start the socket, I will send the same packet because I'm in the active side. Right? After sending the same packet, I will wait for what? Three-way handshake, right? I send the same. I'm active side. I will wait for reply of the same, which is called same add. Okay? So I'll wait for the same add. After I enter the next stage, I'm sure that because I receive the same add, right? I can just send a third message and declare that I am in an establishment status. What is established? Established state is the period that we can exchange data. Okay? On the other side, if I'm actively closing the connection, then I will enter a phrase that I send on the fin. Okay? I send fin, send on the fin, and then wait for the reply from the other side, the second message. If I receive the second message, but the second message is just an ACK, okay, then I will enter the next phase. What is that phase? No one remember? It's this waiting period. I enter this waiting period and wait for the third message to come. The third message come in, and then I will enter the time wait status. Okay, so this is active, this is the passive. Okay, And the remaining slides are just animation, okay? I want you to read it in your home, okay? Because I'm running out of time. Okay, what is the meaning of running out of time, okay? I only handle the first half, okay? After the first half, I need to pass the time to Patrick. So here is just something that you can trace by yourself, okay? You can look at the trace. Now we go to something even more important, to relate TCP handshakes to your assignment. This is making sense, right? What is the meaning? I will relate three-way handshake, four-way handshake with programming. You know, in your assignment, the server side, you will do this, right? Socket, bind, listen, and accept. Okay? And in the client, you don't call bind, right? Socket and then connect. How this 6 core relates to the, not 6 core, okay? Double count the socket, right? 5 core, okay? This 5 core relate to the three-way handshake, four-way handshake. Let's see. Okay? So, what is the meaning of socket? I don't know whether I have explained it clear enough, okay? The socket call is just give you a, file descriptor. Number 3, number 4, number 5, okay? And at the same time, you don't do anything related to the network. You just create TCP structure, receive buffer, send buffer, or a state diagram initialization, something like that. Okay? So this is not about three-way handshake and four-way handshake. The bind call, still remember bind call? The server needs to bind a port number. Did you ever find that the bind fail? If the bind fail, usually it's because of the bind call find that the port number is being used. Now you know that it's about a port number. So bind call is not about connections. Okay? Any problem? Listen. What is the listen mode? Listen mode is important. You have a TCP socket, you create a socket, you bind a port, you not bind a port. Doesn't matter. Whenever you call listen, it means that to tell the kernel that I'm ready to listen for incoming call. What is the meaning? Yeah, this means a lot. What is the meaning of a lot? This is my capture of my machine. Okay, whenever I type this number side, do you know what is the meaning? When I type this number side, it means I'm the root. I'm the root, so that I can see all the system information. Okay, so what is this nested call? Nested call or show all the connection or show all the ports. I'm only interested in TCP minus T. Don't look up any names, okay? I just want raw IP address. You create socket and then ask the system to list all the connection, will show nothing concern your connection. Fine, don't tell you anything. But if you can listen, you will immediately find an entry. Let's say your server 1, 2, 3, 4, 5, right? How many of you are not using 1, 2, 3, 4, 5? Yeah, I guess all of you are using 1, 2, 3, 4, 5. Okay, then I will do this check. What's the check? Okay, I guess you also love to know what is the results. SSH, GW, Linux 2 or 1, okay, doesn't matter. To see how many of you are starting a server. That's that. Minus N, minus T, minus A, pipe less. Okay, any 1, 2, 3, 4, 5? Huh? No one doing homework. I'm frustrated. Yeah, you should be during the lecture, okay? Listen to me say and do this homework at the same time. Huh? No one. Anyone in Linux 2? No one? Yeah, some people will hate VM, okay? Oh, no 1, 2, 3, 4, 5. Okay, fine, okay? So what is the listen state, okay? If you are using a computer, okay, if you want to help me, okay, you can log in Linux 2 and start your server so that I can show something, okay? Now, I highlight a row. Highlight row. So what is this line? Do you know what is this line? This line is a program. I don't know what is a program, but it listens to port 22. How do I know it's listened to port 22? Look at the states. Look at the last column. It said listen. TCP states listen. So it means it's just called the listen call, or maybe even called the accept call. And it enters the listen mode. Okay? Any people go to listen to show, we show off together who are the volunteer. Okay? You know what? You guys, do you have a server running that is available in any one of the next? No. Okay, so forget about this. Okay. I would do my own version. Okay, I don't rely on you guys. Okay, so I create a special port number so that no collision. Don't ask me what is this program. Okay. This program will start a server at port 24678. Okay. Then I log in. I log in NX2 again. What is the sound? Can you hear some sound? Okay. Next that, minus N, minus A, minus T, pipe less. No? What happened? What happened? I'm using NC already, right? Localhost. Connection refused. Oh shoot. What happened? Minus A minus P. Alright, yeah. I missed the argument. Okay? So you can see I start a server, listen to this port, and then listen mode. Okay? So this is the way to start a quick server. It's called NC. Okay? So this is the effect, right? When I start call listen, but there is no any packet firing out, no packet, 0. Now when we will have fire, yeah, I choose this icon and add a thing here. Okay, see here. Okay. Here's a rocket thing. The time that you will fire three-way handshake is the time that you call connect. You call connect. Okay. You can sense that, let's say the time is, you start the client, but you forgot to open the server. What will happen? Anybody experience this? No one. You guys don't do assignment. You start the client, you want to connect, but you forgot to open the server. What will happen? Connection refused. Why is that connection refused? Why? Connect call will fire same, right? How come the connect call knows that this thing fire out, but no one tried to respond us? Now this is the next thing. Okay, so this is normal flow. Normal flow is like this. You have a client program here, and still remember the color scheme. My color scheme is always this color is the kernel. Okay, yes, follow the 350 color scheme. Okay. So fire the same, and here is someone constant already. Okay, and when you fire a same, the kernel will do something in parallel. It will parallelly listen to the background, okay, or I should say listen to the background, whether there's the same fire at this point. Why I say that is it's doing something in parallel. Look at your code. After you call listen, will listen block you? Yo, who blocked you? Accept, right? It's accept code doing the block. But you can see that the listen code is actually put the port into the listen mode. So here it means that in the parallel, the kernel already served you by listening to the network, whether there is the same firing at your port. Okay? And if yes, then I will do the three-way handshake. And when the connect code will return, it's time that you send out the third message. Okay? It's time to send out the third message. Now I asked previously, What happens if you have a server, but you didn't start the port, okay, let's say, or you didn't even start the server, but you have the client want to open the connection. You say the same, and here what happened, I just start the listen not fast enough. What will happen? The kernel of the other side will know that because the kernel don't serve you before this time, it will find that, hey, I didn't find any port called 1, 2, 3, 4, 5. Enter listen mode. So the next step is send out a TCP packet called reset packet. Okay? When you receive a packet, you will find that your connect call will immediately return. What is the return value? -1, right? Return value of the connect call -1. And when you look at P error will tell you connection refused. It is only because you receive reset. Okay? And why we reset you? Because I didn't get the port ready, not registered in the listen mode. Okay? So remember this. This is quite important. Now, how about accept? Did you find any place for accept in the diagram? No. I never mentioned accept. Okay? So what exactly is accept? Accept is just to create a file descriptor for you to handle a particular connection. No more. No more. Okay? But you will start puzzling. Then if I don't call accept, what will happen? Have you ever tried? No one tried, right? No one tried. You can try it, right? Say, listen, and then you go to while one sleep. Okay? And capture the packet. You will see something interesting. What is the interesting thing? Here, I didn't write down anything. I don't say I call accept. You can try. Just call listen, and here, do while one sleep 1. Your three-way handshake can still be successfully done. And your client will even know that the opposite side is ready to serve me and have connect call return. But how about here? How about server? The server will enter a funny state. What is the funny state? It knows that I have a contract with you. I signed a contract with you. The contract is, I am ready to serve you. Okay? And who signed the contract with you? The kernel. Because kernel do in the background to involve in the three-way handshake action. Now, after a three-way handshake action, it's supposed that the client will send something to the server. Let's say the LS, okay, no, LS is an authentication, right? After open is authentication. Authentication request. Send out here. Do you think that the server will reply to authentication reply? No, because I enter while one sleep 1. Okay? But for TCP don't care about it, right? I am TCP, I will only control whether the verification is done normally, whether the message is delivered safely and reliably. Okay, so here it means that accept is to give you a better control over the TCP connection, nothing more. Okay, nothing more. Then we go to the four-way handshake. Okay, so what's the time? Four-way handshake. Four-way handshake is interesting. I said that four-way handshake has a time between the server, let's say the client stopped the connection. The server has a time that not ready to close. So what does it mean of not ready to close? Let's see here. Okay, here is the most interesting part of the TCP connection because there are many buggy scenarios will happen. First, you call close. Okay, how many of you find that close is a non-blocking system call? How many? No one. No one finds this is non-blocking. So you guys all think it's blocking. Blocking or non-blocking? Close call. No one even tried to understand. Close is blocking or non-blocking. Yeah, okay, then let's do a pause. Yes, raise up your hand. It's blocking. Close is blocking. Non-blocking. Okay, 1 vs 1. You guys go out and fight, okay? Only 1 vs 1. I would say that's non-blocking. It's not blocking. Okay? So, but if it's not blocking, what will happen? What will happen? Very interesting. Here, close. You just indicate your attention that to the kernel that you don't want to play anymore. You want to close. Then tell the kernel that go ahead and start the forward handshake. Now, once the forward handshake starts, no one can return to the established states. Okay? That means that I really want to close. So that's why we don't need to have a blocking state anymore. Because the kernel knows that you will not be able to talk with the server anymore. So it will return immediately and enter a disconnected mode in the application. But in the kernel, it's entered into some funny things. Now let's talk about the application. What the application will do after close? Can you terminate the program after close? Can you? Yes or no? You don't implement your program. Huh? You just copy and paste it. Am I code? You call close. Then can you terminate the program? Yes. Right? So that means here, although I put a orange color here, we allow the application to die as well. So the kernel side, this green arrow is very important. Because once you say that you don't want to play, want to close, you pass the entire job to the kernel. And the kernel will do the forward handshake for you. One message, two message. Why we have two message here? Here is the kernel of the other side that, okay, I know you don't want to play. But my boss, who is my boss? My boss is the application. The application don't think that we are ready to close. Let's look at what the application is doing. The application is doing some green things. I don't know what's green things. Maybe green things waiting for the user to type things or doing some computation. I don't know. But eventually, now imagine your case, okay? In your case, the server. The server will always reading things, right? Just keep reading. And when the other side don't want to play, what is the return value of read call? 0. Yeah, you will return 0. So here is the chance. Once you call read, and the server finds that, hey, the other side don't want to play, let's tell the application. Tell the application that, oh, the other side don't want to play, and no more data for you, return 0. Now it is your choice, your server choice, to close or not to close. Okay? To close, then you call close. This call is actually generating the third message of the forward handshake. This is time. Okay? So that means what? That means you can enter a very funny state. This application never call close. And the forward handshake never finish. Yeah, it is allowed. It is allowed. And here, this side, although the application has gone, okay, already terminated the process, the kernel will serve you until you reboot the computer. Ah, very interesting case, huh? Here, how about here? Okay, I call close. Then you will start telling the other side that, okay, I'm also ready to close. Let's finish the job. Give me the last ACK. Give me the last ACK. Now, when the last ACK arrives here, it is safe for the server to close the socket. How about the client? The client needs to wait for time. Time waits, let's say it's one minute. Okay? Now, that's why I said that what if this fin at this ACK lost. This thick green guy will still be here. We transmitting this fin at, but this green guy is still here, able to accept the retransmission, and we transmit the egg. Understand? So why I said this is funny? Because you can enter many bucky modes. What happened if this ACK keep losing for 1 minute? Then it will be very funny. This guy will close the socket after 1 minute. This guy keep like a stupid boy, okay? Keep sending FINAF, but no one replies you. If it is losing this connection from this area, okay? So you will end up many funny things, many buggy things. I check with the TCP specification, they allow all this scenario to happen, and I check with the wireshark capture, all special things you can think of may happen in this closing period. Okay, but the system call relationship, I draw it here, all there, the close, the moment of close, the return value of read. You all experience that, right? When the other side don't want to play, you will receive the return value of read 0, and this is why. Okay? So this is the end of this part. Any questions? Any question, any funny case you want to describe, and we can discuss together. No? Yes?
我想問可唔可以four-way handshake 係咁樣啦嚇？
啊，OK。
咁樣啦嚇，可唔可以淨係一邊 close 咗，但係另一邊繼續 send message 咁樣？所以冇人會 read。
I experienced two cases. My first experience is I can send a film. Then suddenly I receive reset. I don't know why. Second scenario is I immediately receive reset. I don't know why. I have this kind of capture, but I need to find. Yeah. Any other questions? No? Okay. Then we will, not then, okay, we will end this lecture.